I was here, unfortunately, so I couldn't
Okay.
see it. That's why I'm also trying to find out how did you feel of your experience at Excelvator
I had
so far?
fun. It was good. Yeah, a good audience. They respond and they seem interested. The space was full. That's really good. I will gather more feedback in the next 2 hours.
Definitely. And let's hear some of the questions from the audience.
Hello. Can you please define the notion of quantum technology without using the word quantum?
Atomic. I will use atomic. So I'm going to try not to use the word. The atomic world, there are different kinds of physics. Most of us at school, we learn Newtonian physics, which is acceleration, force, the gravity, how the apple falls from the tree. And that's how basically how our brain works, right? And you understand that if you have something in the air, it's going to fall because of gravity, and you can calculate the acceleration. That's most of how everybody is educated in school. There is another kind of physics. Once you go into the atomic level, and if you look at your skin, I will give you the example. Imagine your eyes had a microscope, and you could go into the atomic world. The atoms have the center, the nucleus, with the electrons going around and moving. And in fact, most of the space is empty. There's a like 50x time between the nucleus and the space of the electron. So in reality, most of your arm is empty. There's vacuum there. And the electrons are moving. But you cannot see them moving right now, right? But they are. There's a lot of things happening at the atomic level in your hand right now, in everything physical, in everything. So the equations that explain those behaviors at the atomic level, it's what is called, I'm sorry, I have to use the word, quantum mechanics or quantum physics. It was first kind of discovered at the beginning in the at the end of the 19th century. They discovered that the smallest particle was an atom. Then they discovered that the atom has charges, positive and negative. And then they discovered that those charges were moving around. And then there was the big revolution was in 1927 in the Solvay conference, where it's called the smartest picture in the world because you have, I think it's 14 or 17 Nobel Prizes in one picture. Einstein was there and many others. And they sat down together for a week and put together all those ideas that could explain the behaviors at that small scale. Because the equations that we learn from Newton don't apply at the small scale. So there's a different world, a different way of things, how they behave, and how they interact with each other. And those ideas in the next 20, 30, 50 years that got proven empirically in science in the labs. So what was an idea, then it got proven, so it always worked, that becomes a formula. And that becomes a proven empirically methodology. Now, because that's when the MRI came in the 1970s, 80s. That's why the MRI is a kind of a magnetic field, but it's photonics, transistor, GPS. They all have some physics, quantum physics phenomena based on it. In the last 10, 20 years, what happened is that with the progress of AI, because at the atomic world, it's so massive. If you want to simulate, for example, just the water particle is H2O, that it's only three, two H's and one O. It's massive computation because you need a lot of compute power to run all those calculations of atoms. We never had that power in compute. Today, with AI and the power of compute of GPUs, we can start modeling and understand much better that world that it's so at the tiny phase. Did that help?
A bit, but by that logic, couldn't we say that everything around us is quantum technology because it is made of, like this water bottle is atomic technology because it is made of atoms?
Yeah, and there is a point where, and this is what, for example, the theory of everything, Stephen Hawking's, and what the grail of physicists is trying to connect all the physics, like one formula or some equations that makes you understand when do we go from the quantum physics to the Newtonian physics. At what point do I stop behaving, using those equations to understand how things behave, to understand the physical world, and using the other equations. And then you go to space, and you have the gravitational physics that have different behaviors. So, yes, at some point, you can accept that at some point everything is atomic because everything is made out of atoms. So if we understand that, we can understand better how to build a better plastic bottle. because plastic is just a combination of chemistry, it's a combination of atoms put together. If we're able to simulate and put together atoms that have the same resistance, the same properties, but are more sustainable, then we can solve the problem of plastics and have a different new material that protects the water that you're carrying right there without being contaminated.
Thank you.
He is first.
Thanks. So I have some background in physics, but I recently found out that quantum mechanics at the deepest level has this thing called a standard model, which explains all the matter or stuff. And I found out that that thing is really just a mess. I mean, it has 19 parameters, and it just seems like it's only duct tape stuck with, I don't know, iron or boards or something. Do you have an opinion on this, or how proud are we of quantum mechanics? Because there are some ideas that are really good, but then when you look at this standard model, it's really a mess. Thanks.
I am not a physicist, so I will ask our physicists to answer that question correctly. I can tell you from what I've learned in quantum mechanics that it's a never-ending world. Like it can get very confusing at some point. But part of your question was what have we learned or we doing? Like the big example is there are many areas inside quantum mechanics or quantum physics. Some of them are still trying to be assessed and try to bring into a real application in the world. But the three examples that I gave before, a transistor is based on photonics. Most of photonics are based on quantum physics phenomena because it's laser and it's light. And transistor has been, they call it the biggest invention of the 20th century, which has made possible all the computation. That's a quantum phenomenon. GPS has a quantum physics component to try to calculate the real timing for the signal to arrive at the same time in the locations. The MRI sensors, those have quantum components, so there are a lot of applications. And we are just, with the progress on AI and other technologies, we are just uncovering many other applications of quantum mechanics, including quantum computers. Quantum computers is one application of using quantum physics to do computation. But we are going to uncover many more in the next 5-10 years, just because other technologies are allowing us to use those theories that were in the lab, in the shelves, just waiting there for us to be used. Same as AI. AI is not something new that came in the last 10 years. AI has been there since the 1960s or 70s, depending on how you count it. Just went through a few winters. And today, thanks to the progress in hardware and the ability to manage big amounts of data, we are able to use AI as we always wanted. But AI has been there for 50, 60 years. Quantum mechanics has been there for 100 years. I don't really answer your question. I'm not I'm learning inside physics there are many, many fields, and impossible to be an expert in all of them. I'm only an industrial engineer.
Thanks. Let's hear the next question.
Yeah. First of all, thank you for the presentation. It was really eye-opening. I connected with it in the way that I experienced the jamming of the GPS signal. And back then, I didn't know what happened. I was near a conflict zone, but now I know. My question for you, you talked about a new wave of sensors that are immune to interferences. They are now in the size of a shoebox, but in the future they will be integrated in phones. Do you have such examples and the timeline of when we can expect this kind of sensors?
Well, in fact, depends what kind of sensor and to do what. You already have some quantum hardware inside phones. I think Samsung and maybe Nokia announced that they have a quantum random QRNG, quantum random numbers, which is basically when you want to protect your data, you have to generate randomness to create the numbers that you want to use. And there's a quantum phenomenon to create the best random numbers possible. You can create a very small device that you can put in your phone to create that randomness. So technically, you already have quantum hardware inside your phones. For the GPS part, I don't think I can give the location part, the magnetic navigation part. I don't think I can give an estimate, but we are right now doing a lot of progress in terms of you need to start creating all the map of the world, and then first airplanes, probably also ships, cars, self-driving cars are going to need this desperately, because if they lose where they are, there's no one there to say, I'm going to go to the right or to the left. And little by little, you get there. I can't give an estimate, but we know it will happen.
Thank you.
Great. Any other questions? Yes, in the back there.
Thank you. It was a really amazing speech. I would like to know more about what are the challenges you face when communicating about your business, technology, like how humans understand what you're talking about and how you solve this.
It's a good question. My mother still does not understand what I do, which is fine. My wife has learned to explain it after 100 times. So you have to really adequate yourself to the audience. That's why days like today will be complicated, because you don't know how. You have both a mix of technical and non-technical people in the audience. It's not the same thing if I talk to a physicist that if I talk to the board of directors of a company. So it depends who your audience is. You want to adapt the message and the level of granularity that you're going to. To a CEO, they will care about what exactly is going to disrupt their business in the next 5 to 7 years. What do they need to start doing now to be leaders or continue their position in 5 years? To a government official, it's similar but in a different way. It's like, how do I allow my citizens to catch up and have my nation to not stay behind? Where do I need to invest in research labs or universities, talent, etc.? When you talk to the technical people, you probably want to talk about the papers that your team has published, who is in your team. For example, we've gathered probably the best and most competitive cryptography team in the world. And that's something that attracts a lot all cryptographers and all the cybersecurity experts, because it's a small community and they recognize each other. So they say if person A, B, C are in that team, that means they're doing something good, because those people will never work on something that is not impressive. And then they start coming around it. So talent is very important. And then, yeah, if you talk to your friends and everybody else, you try to, I think examples are very useful. That's why the presentation today, I talked very in the superficial level of the concept, but I try to give more the examples of what we are exactly doing. Because if I tell you, if you merge AI with quantum mechanics, you can change the world today, that doesn't mean anything to you. But if I tell you we put in a device in an Air Force airplane and we are able to know where we are by analyzing the data and denoising the data, and an airplane that was lost is not lost anymore, that rings a bell in you. That allows you to say, okay, that's how they're doing it.
All right. Any other questions? Going once.
Perfect.
All right. If there are no more questions, Fernando, thank you so much for sharing your knowledge with us. Thank you for coming to Tech Sylvania, and thank you for the interesting questions from the audience.
Yeah, thank you.